Okay, for question number 1, this is the question. So now first of all, we take a look at the numbers with index. So over here, numbers with index would be these two numbers. And we know that the bases are the same. So since the bases are the same, we just need to take care of the index. So what I can do is, first of all, I will expand the power. This is 2x plus 2 plus 3, and then multiply with 2 power x. This is equals to 1. Now, from the first term, I can break it into two parts. That is 2 power 2x multiply with 2 power 2 plus 3 times 2 power x equals to 1. So this will give me 2 power 2x multiply with 4 plus 3 multiply with 2 power x equals to 1. Next step, since our bases are the same, we will now take a look at our index. I have 2x and x. So over here, I'll choose the easier one, which is x. So I'll change this to 2 power x, multiply with 2 for the power, and I'll multiply with 4 plus 3 multiply with 2 power x equals to 1. Take note that these two terms are now the same, 2 power x. So now I can proceed with substitutions. I let y equals to 2 power x. This will give me y squared multiply with 4 plus 3 bracket y equals to 1. Arranging this, I get 4y squared plus 3y minus 1 equals to 0. This is a quadratic equation. So I can factorize using the calculator and I see what I get. So over here, I will get 4y minus 1 and y plus 1. So now solving, I get y equals to 1 over 4, y equals to negative 1. I have two values of y, but in this question, I'm interested in finding x. So go back to my substitution. When y is equals to 1 over 4, 2 power x is equals to 1 over 4. 1 over 4 can be written as 1 over 2 power 2, which also can be written as 2 power negative 2. So since the bases are the same, over here I can write x to be equals to negative 2. Another solution, when y is equals to negative 1, 2 power x equals to negative 1. Over here, I will not have any solution because 2 power x will always be positive. In fact, it will always be greater or equals to, it will always be greater than 0. It will always be positive. So this one here is invalid. So I only have one answer, therefore x equals to negative 2. Now for question number 2, I have 3 plus Z3 over 2 plus Z3, and then I'll plus it with Z3. I'll do step by step first. Remember, without using calculator. So now, first of all, how to solve for 3 plus Z3 over 2 plus Z3. We have Z at the denominator, so we will consider rationalizing. So now I have 3 plus Z3 over 2 plus Z3. To rationalize it, I'll multiply with its conjugate. The conjugate here is 2 minus Z3. Okay, this is for the first term, and then I'll plus it separately with Z3. So now we can write in this form. Okay, I can do front, 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 back, back, front, back, back. This will give me 6 minus 3 Z3 plus 2 Z3 minus 3. And the denominator here, they are the conjugate of each other. So I can do front, front, and back, back. So this will give me 4 minus 3. Don't forget, I have a plus 3. I have a plus Z3. Now solving it, this will give me 3 minus Z3 over 1. Then plus Z3. This one here, divide by 1 means that I'll get back the answer, that is 3 minus SURD3. And don't forget to plus SURD3 again. Here, these two will cancel, and I'm left with 3. Now for question number 3, logarithm. So first of all, check the bases first. The bases are not the same. I have bases of 2 and x. Choose the easier one. The easier one will be base 2. So I'll maintain my log base 2 of x. I'll change the second term. So this will give me 3 multiplied with log base 2 of 2 over log base 2 of x equals to 4. This is log base 2 of x plus with 3 multiplied with 1 over log base 2 of x equals to 4. Notice that these two logarithm, log base 2 of x, they are the same, so I can play with substitution. So let y equals to log base 2 of x. This will give me y plus 3 over y equals to 4. I have y at the denominator, so I'll multiply everything with y. So now I have y squared. 3 over y times y will give me 3. And then at the right hand side, I have 4y. Quadratic equation, I'll send everything to the left hand side. Next step, I will now factorize. So I have y minus 3 and y minus 1. Sorry, I made a mistake here. This will give me y squared minus 4y plus 3 equals to 0. So here this is y minus 3 and y minus 1 equals to 0. So I have y equals to 3 and y equals to 1. Two solutions over here, but I'm interested in x. So I'm going to solve for this one. When y is equals to 3, 3 equals to log base 2 of x. Play with your index form. So now I'll get 2 power 3 is equals to x, x is equals to 8. And the other side, when y is equals to 1, so when y equals to 1, I have 1 equals to log base 2 of x. So this will give me 2 power 1 equals to x, x is equals to 2. For logarithm, I have to check my solution. So now what I can see is just check the nature of the number. When x is 8, does the logarithm exist? It will exist here. It will also exist as the base when x is equals to 8. And for x equals to 2, it will also exist. So now I have two answers, combine them. Therefore, x is equals to 2, x is equals to 8. Now for the last question, this is solving the system of linear equations. 3 equations here, so I'll name them equation 1, 2, and 3. Then I identify which one I want to kill. So looking at these three equations, it will be easiest if I would want to eliminate my z. Okay, eliminate my z because the coefficient of z are the same for all these 3 equations. I'll fix my equation 2. So now what I can do is I can do equation 1 minus equation 2. So this will give me negative 10x plus 6y equals to negative 1. I name this equation 4. I fix my equation 2, so now I can also do equation 2 plus equation 3. Because my aim is to eliminate z. So now I have 4x equals to 16. So x is equals to 16 over 4, which will give me 4. So now I already got my variable of x, so I can go backwards. And this time I'm going to play with equation number 4. Choose the easiest one. So from equation 4, I have negative 10 times 4 plus 6y equals to negative 1. So this will give me negative 40 plus 6y plus 1 equals to 0. This is negative 39 equals to negative 6y. I can cancel the negative at both sides. So y is equals to 39 over 6. Simplifying it will give me 13 over 2. So I've solved for x and y. Last step, I'm going to solve for my z. So to find z, I can play with any of these three equations. Let's say I choose equation number 2. So from equation 2, I have 6x, which is 6 times 4, minus 4y is 13/2, plus 2z equals to 2. So this is 24 minus 26 plus 2z equals to 2. This will give me negative 2 plus 2z equals to 2. 2z will be equals to 4, so z is equals to 2. Therefore, I have x equals to 4, y equals to 13/2, and z equals to 2.